Welcome to the Thinking Abyss podcast, a philosophical journey through consciousness, reality, and the phenomena that challenge our understanding of existence. From ancient wisdom to cutting-edge theories, we explore where philosophy meets science and curiosity leads to the edge of the unknown.
Welcome back, everyone. So today, I want you to imagine something with me.
Okay, I'm ready.
Imagine we're walking. We're moving fast, feeling confident. We're covering ground that we know perfectly well.
We have a map.
We have the ultimate map. I mean, it is so detailed. It shows every single blade of grass, every pebble, every dip in the terrain. It's the perfect guide.
We feel totally in control. We know what's coming next.
Exactly. And then all of a sudden, the ground just stops.
We run out of land.
We run out of land. We are standing right at the edge of a cliff, toes hanging over the edge, and we're just looking out into this thick, impenetrable fog.
And that map we were holding.
It's useless now. It's completely blank for what's out there in the mist. Today, that cliff, that's what we're talking about. We're doing an exploration of the absolute edge of what we can know.
It gives you a bit of vertigo just thinking about it, doesn't it?
It really does.
Because usually when we sit down to talk about science, especially physics, it's a celebration. We're always talking about the triumphs.
Yeah, we're popping the champagne corks over what we know.
The discoveries, the incredible, almost unbelievable predictive power that we have over the physical world.
And we should. I mean, I don't want to start this off sounding like we're being pessimistic about science. Think about where we came from as a species.
Oh, absolutely.
A few thousand years ago, our ancestors, they looked up at the night sky, saw all these little points of light, and what do? They made up stories. Bears, hunters, gods.
To try and make sense of it all.
Right. And today, we look up at that same sky, and we don't just see lights. We see nuclear fusion reactors.
Burning hydrogen into helium at 15 million degrees Celsius.
Stabilized by their own gravity, sitting at these precise distances that we can calculate down to the decimal point. It's staggering.
It is, by any reasonable definition, miraculous. And I use that word very carefully.
That's a strong word for a scientist.
It is, but the success of physics isn't just good. It is, unreasonably good. We can explain why the sky is blue.
And not in a fuzzy way. It's not just paint.
No, it's Rayleigh scattering. It's the specific, quantifiable way that photons interact with nitrogen and oxygen molecules in the atmosphere. We know why the sun shines. We can predict, with unnerving accuracy, where Jupiter will be on a Tuesday night in the year 2095.
That's the part that always gets me, the prediction. I mean, it's one thing to explain why something happened after the fact, right? Historians do that all the time.
Of course.
But physics says, hey, listen, if you build this particular circuit, or you mix these two chemicals in these amounts, or you launch this rocket at this precise angle, this exact thing will happen. And then it does.
It's like having the cheat codes for the universe.
It really is.
And that predictive power is the absolute hallmark of the field. And there's this profound, economy to it all.
What do you mean by economy?
Well, you look out at the world and you just see chaos, right? Crashing waves, trees growing, lightning storms, water boiling in a pot. It all looks impossibly complex.
It's a total mess.
But physics comes along and boils all of that complexity down to just a handful of fundamental principles, a few equations on a page.
Maxwell's equations for electromagnetism. Einstein's field equations for gravity.
Exactly. It's so elegant, it suggests that the universe is, at its core, legible.
Legible. I like that. It's readable. But, and this is the massive but that our whole discussion today is about, we seem to be hitting a wall, a hard wall. And I want to be really clear for everyone listening. We aren't talking about things we just haven't figured out yet. This isn't a case of, we don't know what dark matter is, but just give us another 50 years in a bigger collider.
No, that's a crucial distinction to make right up front. We are not talking about temporary gaps in our knowledge. Science is full of those. And that's the fun part. We fill them in over time.
That's the day-to-day work.
It is. What we're talking about today are fundamental, maybe even permanent limits, structural boundaries. We're going on a journey into the difference between explaining how the world works, the gears, the levers, the mechanisms, and explaining why the world is the way it is, or, even more profoundly, why it exists at all.
So there are these specific domains where physics, by its very nature, just it goes silent.
It has nothing to say.
It's like we have the most incredible detailed instruction manual for a car ever written. We know exactly how the pistons fire, how the transmission transfers torque, how the fuel injectors atomize the gasoline.
Every single mechanical detail is laid out.
But if you ask that manual, hey, why was this car built in the first place? Or where am I supposed to drive it? Or even, who is the driver?
The manual just stares back at you blankly.
The pages are empty.
That is a perfect analogy. The manual explains the mechanism, not the meaning. And today we're going to flip through the parts of reality that are strictly off the manual.
Okay, so where do we begin? Let's start at the absolute beginning. And I don't mean the start of our conversation. I mean the start of everything.
The prime question.
Why is there something rather than nothing?
This is the one. The question that has kept philosophers and, let's be honest, insomniacs awake for millennia.
I can believe it.
Physics is incredibly good at what we call dynamical evolution. If you give a physicist a starting state, a box of particles, some fields, the laws of gravity, they can tell you exactly what's going to happen next. They can evolve that system forward in time with incredible precision.
Right, it's an algorithm. Given X, then Y happens.
Precisely. But physics takes X for granted.
It assumes the box of particles is already there.
It assumes the existence of the stage itself. It assumes there are particles. It assumes there are fields and that they behave in certain ways. It assumes the laws of mathematics hold true, but it cannot explain why those things are there to begin with. Why is there a stage at all?
But hang on a second, because I've read the pop science books. I've seen the headlines that say, universe created from nothing. Physicists talk about this all the time. They say the universe could have just originated from a quantum fluctuation.
They do, yes. That's a very common idea.
So walk me through that.
Yeah.
Because to a layperson like me, that sounds a lot like an answer. You have a vacuum, you have the laws of quantum mechanics, a bubble of space-time pops into existence, and boom, you get the Big Bang. Problem solved. Right?
It sounds like a solution, doesn't it? It feels very satisfying, but it's actually a bit of a semantic trap.
How so?
When a physicist says the word nothing in that context, they don't mean absolute philosophical nothingness. They don't mean the total absence of everything, no laws, no potential, no anything.
So nothing is actually something.
It's very much something. A quantum vacuum is a seething, bubbling field of potential energy. It is governed by incredibly complex physical laws. It has structure. It has rules. It obeys mathematics. So if you explain the origin of our universe by saying it came from a quantum fluctuation, all you've really done is assume the pre-existence of quantum laws. You've assumed the existence of a vacuum state that allows for those fluctuations to happen.
So you haven't actually explained existence at all. You've just pushed the question back one step. You still have to ask, okay, but where did the quantum laws come from?
Precisely. This is the classic problem of infinite regress. It's what philosophers sometimes call the turtles all the way down problem.
Right, the story of the woman who says the world is on the back of a giant turtle. And when asked what the turtle is on, she says, another turtle.
And it just keeps going. If you explain our universe, let's call it A, by appealing to a set of quantum laws, B, you now have a new problem. You have to explain B. If you say B comes from some kind of multiverse or a super law, C, well, now you have to explain C.
And you can just keep doing that forever. Why C because D? Why D because E? It never ends.
And an infinite chain of explanations doesn't actually explain anything. It's just deferring the answer into infinity. So you inevitably hit a dead end. And at that dead end, you have basically two options.
Okay.
One, you accept the infinite regress, which is deeply unsatisfying. Or two, at some point, you have to stop and say, this just is.
A brute fact.
A brute fact.
Yeah.
You reach a fundamental layer of reality. Maybe it's the laws themselves. Maybe it's the initial state. And you have to just admit, there is no deeper reason for this. It just exists.
Which is incredibly frustrating for a species like ours that is just obsessed with the word because. We always want a reason for everything.
We do. And there's a third door, of course. You can step outside of physics entirely. You can appeal to metaphysics, something outside the natural order, like a creator or a programmer of a simulation or something. But the moment you do that,
you've admitted that physics can't explain it.
You've admitted that the tools of science have failed to explain the very foundation that science itself rests on.
And this connects directly to the Big Bang, doesn't it? I mean, we have this incredible picture of the universe expanding from a hot, dense state 13.8 billion years ago. We can see the leftover heat, the cosmic microwave background. We have proof.
We do. The evidence is overwhelming.
But physics doesn't tell us why it started in that specific way.
Correct. This is what's known as the problem of initial conditions. Think of the universe as a game of pool. If I show you a video of the balls scattering across the table after the break, you can use physics to calculate all their trajectories, their momentum, where they'll bounce.
You can explain everything that happens after the break.
Yes. But physics cannot tell you why the player chose to hit the rack in that one specific way to begin with.
It can't explain the setup.
It cannot explain the setup. Why did our universe start in a state of extremely low entropy? Why was it so highly ordered? Why was it hot and dense instead of cold and empty? Why wasn't it just a chaotic mess where atoms could never form stable structures? Physics can run the film backward right to the first frame, but it can't explain why the director chose that particular image for the opening shot.
And it's not just that it started in some way. It's that it started in a very specific, almost suspicious way. And this brings us to the fine-tuning argument, which I have to say, I always find this one a little spooky.
It's arguably one of the most unsettling discoveries in all of modern cosmology. It's often discussed under the name of the anthropic principle,
Which is the idea that the universe seems to be prepared for us.
in a manner of speaking. What we've discovered is that the constants of nature, these fundamental numbers that define our reality, they seem to be perfectly, and I mean delicately, arranged to allow for the existence of complex life.
So give us some numbers here. How delicate are we talking about? Is it like a watch or something even more precise?
It's far more precise than any watch. Take, for example, the cosmological constant. This is the energy density of empty space, the thing that's driving the accelerated expansion of the universe.
Right, dark energy.
If that number were different by an infinitesimally small fraction, some physicists calculate it as 1 part in 10 to the power of 120.
Wait. 10 to the 120th power? That's a 1 followed by 120 zeros.
That's right, an incomprehensibly large number. If the constant were different by just that tiny, tiny sliver, the universe would have either blown itself apart so fast that no stars or galaxies could ever have formed.
So just a thin, cold gas forever.
Or it would have collapsed back in on itself just milliseconds after the Big Bang.
So it's like balancing a pencil on its sharpest point for billions of years?
It's more precise than that. It's like throwing a dart from one side of the observable universe and hitting a single specific atom on the other side on the first try. And it's not just that one constant.
There are others.
Many others. The strength of gravity, the mass of the electron, the ratio of the strong nuclear force to the electromagnetic force. If you tweak any of them just slightly, you get a dead universe. No chemistry, no stars, no planets, no life.
It really does feel like a setup. It's like walking into a hotel room and finding the thermostat set to exactly your favorite temperature, your favorite snack is on the pillow, and your favorite song is playing softly on the radio.
What would you conclude?
I'd assume someone knew I was coming. I definitely wouldn't assume it was all just a random accident.
And yet a physicist looks at that room and says, well, I can explain exactly how the thermostat works, and I can describe the physics of how the speaker produces sound waves. But they can't explain the arrangement.
The conspiracy of it all.
And to get around this discomfort, because it feels very much like design, a word that makes scientists nervous, some physicists have invoked the multiverse.
Right, the multiverse. This is the idea that there isn't just one universe. There are infinite universes, constantly bubbling up into existence.
That's the idea.
And most of them are duds. They're dead, empty, chaotic messes with the wrong settings. But because you have infinite chances, an infinite number of lottery tickets.
Eventually, one is going to hit the jackpot. And we just happen to live in the universe that won.
It's the ultimate selection bias. Of course, we find ourselves in a life-permitting universe, because if we were in one of the other ones, we wouldn't be here to ask the question.
It's the firing squad analogy. If you're standing in front of a firing squad of 100 expert marksmen, and they all fire, and somehow you survive, you could say, wow, it's a miracle. Or you could say maybe there are millions of executions just like this one happening today, and I just happen to be the only survivor left to be surprised about it.
It solves the coincidence problem. But
yeah.
I don't know, doesn't that feel a bit like a cop-out?
Many philosophers, and even a good number of physicists, would agree with you it is a massive theoretical leap. And here's the real catch. The multiverse is, at least for now, speculative. It's outside the realm of empirical, testable physics.
We can't see these other universes.
We can't interact with them. We can't test them. So it remains a hypothesis, not a proven theory.
So it's basically a philosophical patch to fix a hole in the physics. It's like metaphysics in a lab coat.
In a way, you could see it like that. And even if it were true, let's just grant them the multiverse for a second. It brings us right back to the very first problem we talked about.
Why is there something rather than nothing?
Why does the multiverse exist? What is this universe-generating mechanism, and where did it come from? Why are the laws of the multiverse such that they produce all this variety? You haven't actually solved the mystery of existence. You've just made the stage infinitely bigger.
Okay, so physics strikes out on explaining the origin and the stage. But surely it can explain the actors on the stage. I mean, us. We're physical beings. I'm made of atoms, you're made of atoms. My brain is just a wet computer made of meat, right?
We are indeed made of atoms, and physics can explain the biological machine with astonishing success. But this brings us to what might be the most stubborn, the most frustrating limit of all.
The ghost in the machine. Consciousness. The hard problem. I love talking about this because it's the one thing in the entire universe we are most familiar with, our own minds, and yet it's the thing science seems completely and utterly baffled by.
And we need to be careful here to distinguish between the so-called easy problems of consciousness, which are actually incredibly difficult neuroscience problems, and the one true hard problem.
Okay, so what are the easy problems?
The easy problems are things like, how does the brain process visual data from the retina? How do neurons fire in a sequence when you touch a hot stove and pull your hand away? How does the brain store and retrieve memories?
These are basically engineering questions. We can put someone in an fMRI machine and see their brain light up. We can say, look, blood flow to the amygdala increases when you show them a scary picture.
Exactly. That is the objective view. The third-person perspective. We can map the correlations between brain states and behaviors, but then there's the subjective view. The first-person perspective.
What it feels like from the inside.
Right. When you look at a red apple, your brain is processing a specific wavelength of light around 700 nanometers. Physics can describe that perfectly, but you also have an experience. You feel the redness. There is what it is like to be you seeing red.
And philosophers call this qualia.
Qualia. The raw sensations, the actual hurt of pain, the sweetness of chocolate, the redness of red.
Well, wait a second. A strict materialist, a reductionist, would just say, the feeling is the neuron firing. They're the same thing. Why are you trying to separate them?
Because they don't seem to be the same thing at all. They have completely different properties. You can describe the neuron firing with perfect physical accuracy. You can talk about voltage gates opening, ions rushing in, and neurotransmitters crossing the synaptic cleft. You can describe that entire process using only the language of physics and chemistry.
Okay.
But nowhere in that physical description will you find the property of redness. Nowhere in the equations for ion transfer do you find the feeling, ouch.
Physics has an equation for serotonin levels, but it doesn't have an equation for the feeling of grief.
Precisely. And to really hammer this home, philosophers use this fascinating thought experiment called the philosophical zombie.
That sounds ominous.
It's a bit creepy. Imagine a being that is physically identical to you, molecule for molecule. Every neuron is in the exact same place with the exact same connections. It acts exactly like you do in every situation. If you pinch it, it says, ouch, and pulls its arm away. Its brain processes the damage signal perfectly.
So from the outside, it's indistinguishable from me.
Indistinguishable. It behaves exactly like you. But inside, there's nothing. It's dark. There is no experiencer. There is no movie playing in its head. It is, for all intents and purposes, a biological robot.
That is deeply, deeply creeping me out.
It should. But here's the absolute kicker.
Yeah.
From the perspective of physics, that zombie is perfectly possible. There is nothing in physics that says it can't exist.
What?
Because physics only describes the mechanism. It describes the inputs and the outputs. It describes the electrochemical cascade in the nerves in the brain. But absolutely nothing in the standard model of physics explains why that physical cascade must be accompanied by a private, internal, subjective experience.
So physics can explain the zombie, but it can't explain me. It can't explain the one with the lights on inside.
This is what's called the explanatory gap. You can pile up all the neuroscience, all the biology, all the physics you want, building a bridge from the bottom up, from the atoms, but you never actually cross the gap from matter moving around to mind feeling things.
And this leads to a really profound kind of isolation, doesn't it? This is the so-called problem of other minds.
It's the ultimate paranoia, if you think about it too much.
Because, I'm looking at you a little suspiciously right now.
Yeah.
How do I actually know that you are conscious?
You don't.
Great. That's very comforting. Thank you.
Think it through. I can measure your brain activity with an EEG. I can hear your voice. I can see you nodding your head and reacting to what I'm saying. But those are all physical, external behaviors.
They're all third-person data.
Exactly. I cannot measure your experience. I cannot jump inside your head and be you for a second to check if anyone's home. For all I know, you could be a very sophisticated philosophical zombie designed to host this conversation.
Well, I promise I'm not. I am having a very vivid internal experience of anxiety right now. Thank you very much.
And I believe you. But I believe you based on inference, not on physical proof. I assume you're conscious because you look like me and you act like me, and I know I am conscious. But physics itself cannot prove it.
And this gets even messier and more ethically fraught when we start talking about animals, right?
Absolutely.
Does a dog feel pain? Well, we assume so. It yelps. It has a similar nervous system to ours.
Yeah.
But what about a lobster? It struggles when you put it in boiling water. Is that a pain experience or just a reflexive action? How about a fly, a bacterium, a plant? Where on the spectrum do the lights turn on?
Physics can't tell us. It can describe the complexity of the nervous system, but it can't point to a consciousness meter and tell us where the threshold is. Does a sophisticated AI chatbot feel anything? It acts like it thinks. It uses language creatively. But is there anyone home? Physics deals with the objective and the measurable. Consciousness is, by its very nature, subjective and unmeasurable from the outside.
We're trying to find a ghost in the machine using a voltmeter. It's just the wrong tool for the job.
Precisely.
So,
Wow.
you have a universe we can't explain the origin of, filled with conscious observers whose experience we can't explain. But at least, at the very, very least, we have control over our own actions, right? I chose to come to the studio today. I chose to drink this coffee. I am in charge of me.
Did you?
Oh, don't do this to me. Not free will.
We have to go there. We're at the edge of the map. We are wading right into the icy waters of free will versus determinism. And if you take physics seriously, this water is freezing cold.
This is the one that can give me a genuine existential crisis on a random Tuesday afternoon. Because the logic just seems so airtight, it's like a trap.
Lay it out.
Okay. If the universe is just atoms obeying fixed physical laws, right? Atoms hitting other atoms, and my brain is made of those same atoms, then my thoughts are just atoms hitting other atoms.
That is the deterministic trap in a nutshell. If you look at classical physics, Newton's laws, the universe is a giant clockwork mechanism. State A inevitably leads to state B, which leads to state C. The state of the universe right now is the direct mathematical result of the state of the universe 1 second ago.
Which was determined by the state a second before that, and so on, all the way back to the Big Bang.
All the way back.
So if you had a supercomputer powerful enough to know the position and momentum of every single particle at the moment of the Big Bang, you could have, in theory, predicted this entire conversation 13.8 billion years ago.
In a strict deterministic physical view, yes. The particles in your brain are just obeying the laws of electromagnetism and quantum mechanics. They don't have opinions. They don't have a little soul or self that can step in and intervene. They just move according to the laws. So the question is, where is the you that interrupts that causal chain to make a choice?
But I feel like I'm choosing. I feel the struggle of it. Should I have the donut or the salad? That internal debate feels absolutely real. It feels like I'm in the driver's seat.
And that feeling is powerful. To try and rescue this, many philosophers and some physicists advocate for a position called compatibilism.
Okay, what's that?
They argue that we're defining free will the wrong way. They say free will isn't about violating the laws of physics. It's simply the absence of external coercion. If nobody held a gun to your head and forced you to eat the donut and you acted according to your own internal desires, then you acted freely.
Wait. That sounds like a total cop-out. You're just redefining the word free to make yourself feel better.
Explain the problem with it.
Well, okay, so I'm acting according to my desires. Great. But where did those desires come from? I didn't choose to have a brain that loves the taste of sugar. I didn't choose my genetics, which might predispose me to certain preferences. I didn't choose my upbringing or my culture or my brain chemistry. If my entire system is programmed by factors outside my control to want the donut, then choosing the donut isn't freedom. It's just the execution of the program.
Okay.
It's a software script running to completion.
You hit the nail right on the head. That is the fundamental critique of compatibilism. The philosopher Schopenhauer famously put it this way. Man can do what he wills, but he cannot will what he wills.
I can't choose my own desires.
And if your desires are determined by a long chain of prior causes that you didn't control, can you really be said to be free?
So I'm just a puppet who happens to love his strings.
It's a dark way to put it, but from a strictly physicalist determinist standpoint, yes. Now, usually when people get cornered like this by determinism, they start looking for an escape hatch, and they almost always point to quantum mechanics.
Right. The get-out-of-jail-free card. The Heisenberg uncertainty principle. We learned that at the subatomic level, the universe isn't a perfect clockwork. It's fuzzy, it's probabilistic, particles are random. So if the very base of reality is random, then the future isn't written in stone. I'm saved.
Slow down, slow down. It is absolutely true that quantum mechanics breaks strict classical determinism. It introduces a fundamental element of probability into the universe. An electron isn't at a definite point, it's a cloud of probability. But does that actually save free will?
I really hope so. It means my choice isn't predetermined.
It means it's not predetermined, sure, but you've just replaced determinism with randomness. Think about it. If your decision to come to the studio today was the result of a truly random quantum fluctuation, a roll of the cosmic dice in one of your synapses, is that freedom?
Well, no, that's just an accident.
Exactly. If your arm jerks because of a random muscle spasm, you don't proudly say, I chose to move my arm. You say, my arm twitched. Randomness is not the same as autonomy. We want our choices to be ours, to be reasoned, intentional, and authored by us, not just statistical accidents happening in our brain.
So physics leaves us with two equally bad options. Option A, we are clockwork robots following a pre-written script.
Or option B, we are roulette wheels, spinning wildly based on random quantum events.
And neither of those options looks anything like the free will we all feel we have every second of the day.
Physics describes the motion of the particles that are involved in the process of decision-making, but it cannot seem to find the decider in the equations. The agent is missing from the picture.
It's like being stuck between a rock and a random number generator.
I hate it. It is deeply uncomfortable. But let's shift our gaze for a moment. Let's move from the actors on the stage to the very architecture of the stage itself. We've been talking about physical stuff, atoms, brains, stars. But physics relies completely on something that isn't physical at all. The invisible architecture, this is such a profound mystery, and it often gets overlooked just because we're so used to it. The laws of physics are written in the language of mathematics. But why?
Yeah, the physicist Eugene Wigner wrote a famous paper on this called The Unreasonable Effectiveness of Mathematics. Why on earth does the universe obey these abstract, seemingly man-made rules? Or did we even invent them?
That is the great philosophical divide. It's Platonism versus physicalism. The Platonists argue that numbers and mathematical structures like circles and triangles exist independently of human minds.
They're real.
They're real abstract objects. They exist in some kind of non-physical realm beyond space and time.
So when Einstein figured out LFR, he wasn't inventing a catchy tune. He was discovering a continent that was already there.
That's the Platonic view, yes. Think about prime numbers. The number 7 was prime long before humans evolved to count. It will still be prime after the sun burns out. It seems to have an objective, timeless reality. But if you're a strict physicalist, you say only physical things exist: matter, energy, space-time. So, where do numbers live? They don't have mass. They don't have a location in space. You can't trip over the number 4.
Yet the entire universe follows mathematical rules perfectly. I mean, think about antimatter. Paul Dirac didn't discover antimatter in a lab experiment first. He found it in an equation. The math told him it had to exist as a solution.
And years later, we went and found it.
Exactly. The math led the way. Reality seems to be deeply structured by these abstract, non-physical entities. But physics itself cannot explain why. Physics uses mathematical axioms. These are fundamental assumptions, like A plus B equals B plus A, but it doesn't prove them using physics. You can't put the number pi in a particle accelerator to see what it's made of.
So the very language that physics is written in math is something that physics itself cannot explain. It has to borrow it from the philosophers.
It does, and this touches on something even more basic, how we connect events together, the idea of cause and effect. We just assume that A causes B, but that's a bit of a black box too. This is David Hume's problem, isn't it?
The great Scottish skeptic himself. Hume pointed out something really simple but devastating, he said. We see event A, let's say, one billiard ball rolling and hitting another. Then, a moment later, we see event B, the second ball starts to move. We see the sequence, we see the regularity, we see it happen over and over.
But we never actually see the cause itself.
We never see the force or the necessary connection that makes B happen. We just see a pattern. Ball A hits, then ball B moves.
And physics just describes that pattern with incredible accuracy. It gives us equations that say, if the position and momentum are this, then the resulting position and momentum will be that.
It describes the regularity, but not the necessity. Why must the second ball move? Is that a law that's written into the fabric of the universe? Or is it just a habit the universe has that has so far never been broken? Physics can't tell the difference.
That makes the whole enterprise of science feel a lot more fragile. We're just making a giant bet that the future will continue to be like the past.
And speaking of the past and the future, let's talk about time itself. Because the universe has a very, very strict habit when it comes to time.
It only goes one way.
The arrow of time.
Right.
And this is one of the biggest headaches in fundamental physics, because here's the dirty little secret. The fundamental laws of physics are, for the most part, time symmetric.
Meaning they work just as well backwards as they do forwards.
Exactly. If you took a video of two particles colliding and bouncing off each other, and you played that video in reverse, it would look like a perfectly valid, physically possible event. Newton's laws, Einstein's equations, quantum mechanics, they don't have a built-in preference for past or future. They just describe change.
But the world we live in definitely has a preference. If I drop my coffee mug and it shatters on the floor, that is a one-way street.
Yeah.
If I played a video of that in reverse, thousands of shards leaping off the floor to perfectly reassemble into a mug in my hand, everyone would know it's fake.
It looks completely impossible. And this is where physicists bring in entropy, the second law of thermodynamics. The idea that in a closed system, disorder always increases.
Okay, so that solves it then, right? Things get messy over time. The mug breaks because there are a million ways for it to be a broken mess on the floor, and only one way for it to be a whole mug.
That explains the probability. It explains why we don't see mugs spontaneously unshatter. It's just statistically absurd. But does it explain the experience of time?
What do you mean by that?
Entropy explains why the future state of the universe is more disordered than the past state. But it doesn't explain the psychological flow of time. It doesn't explain why we feel like we are moving through time from a fixed past toward an open future.
The feeling of now. Physics doesn't really have a now in its equations, does it?
In the block universe view that comes out of Einstein's relativity, now is just a subjective coordinate, like here. Every moment in time, past, present, and future, exists simultaneously, just like every location in space exists simultaneously. The dinosaurs are still existing back at their time coordinate, and we're here at ours.
But that's not how it feels. It feels like we are surfing a wave that is constantly moving forward. We feel the passage.
And physics has absolutely no account for that feeling of passage. The feeling of time flowing is, once again, a subjective experience. It seems to be a feature of consciousness. The physical map says time is just another dimension, but the territory feels like a flowing river.
It's another huge disconnect. Wow, we were racking up quite a list here. The origin of the universe, consciousness, free will, the nature of math, the flow of time. But let's get to the stuff that actually gets us out of bed in the morning, meaning purpose.
The human layer.
Because even if we're just biological robots living in a meaningless, determined universe, we still care about things. We care about truth and beauty. We care about right and wrong.
Let's start with the most basic kind of meaning. Philosophers have a clunky name for it. Intentionality, or aboutness.
Aboutness. That is a clunky word.
It is, but the concept is crucial. Think about one of your thoughts. If you think about Paris, your thought is about Paris. It points to something outside of itself. It has content. It refers to the Eiffel Tower, the cafes, the smell of fresh bread.
Okay, that makes sense.
But now, look at a neuron firing in your brain when you have that thought. It's just a physical chemical event. Sodium ions are moving across a membrane. Potassium ions are moving out. How can a sodium ion be about the Eiffel Tower?
It can't. It's just chemistry. Chemistry doesn't have a topic. A chemical reaction in a beaker isn't about the French Revolution. It's just bubbling.
Exactly. Physical processes are blind. They just happen. They don't have inherent meaning. A pattern of ink on this page is just a specific arrangement of carbon molecules. It only becomes a word with meaning because a conscious mind interprets it. But if the mind itself is just more blind physical processes, where does the meaning first enter the system?
We're back to the same magic trick. You can't seem to pull meaning out of a hat that's filled with only meaningless atoms.
And it gets even harder, even more problematic, when we move from meaning to values, the realm of normativity, the difference between what is and what ought to be.
The famous is-ought problem.
Physics is strictly and only in the business of is. The electron is here. The energy is conserved. Physics can describe what happens, but it can never, ever tell you what should happen.
So if I make a statement like torture is wrong,
What physics hears is something like, The input of certain pain signals into a human nervous system typically causes avoidance behaviors and specific patterns of neural firing associated with distress. It doesn't hear the word wrong.
You can't find the wrongness of torture in an atom. You can't measure evil with a Geiger counter.
It is not an observer-independent physical property of the universe like mass or charge.
But it feels like a fact. To me, it feels just as true as gravity. If I see someone kicking a puppy, I don't just feel like, oh, that's not my personal preference. I feel like they are violating a real, objective law of the universe.
It does feel that way, and that is the problem. If physics is the whole and complete story of reality, then moral facts can't be real facts. They have to be illusions. They must just be evolutionary tricks that evolution programmed into us to make us cooperate and survive.
But most of us just recoil at that idea.
We do. We want to believe that morality is real with a capital R. But to do that, you have to admit that there are real things in the universe that physics cannot detect or explain.
This reminds me so much of the chess analogy you brought up before we started. I think this really helps nail down this idea of emergence and different levels of explanation.
Yes, it's a great way to understand the limits of reductionism. So imagine a game of chess is in progress on a table, and a brilliant physicist comes in to analyze the board. Okay. They can describe the entire board and all the pieces completely and perfectly using only the laws of physics.
Right. They can say, this piece is made of carved wood. It has a mass of 20 grams. It is currently located at coordinates XY. It is moving with velocity v.
You could track every single atom in the night. You could map the gravitational forces between the rook and the queen. You could, in theory, have a complete, perfect physical description of the entire system.
Okay.
But that complete physical description would miss the most important thing of all. The game. The laws of physics don't know the rules of chess. Physics doesn't know what a knight is. It only knows the shape of the wood. It doesn't understand strategy. It doesn't understand sacrifice. And most importantly, it has no concept of checkmate.
Because checkmate isn't a physical state of the board. It's a relational state. It's defined by the rules of the game, which exist at a higher level of description than the atoms.
Exactly. Those concepts, rules, strategy, victory, they emerge from the physical arrangement, but you can't find them in the atoms themselves. You can't discover the rules of chess by smashing the king piece in a particle accelerator.
So if you try to reduce everything down to the level of physics, you lose the game.
You lose the explanation, and that is the ultimate failure of extreme reductionism. The idea that if you just understand the parts, you will automatically understand the whole. You can know everything there is to know about the atoms in a human being and still not understand their psychology, their sociology, or their history.
You can't explain the French Revolution by tracking the particle physics of all the people involved. And then the Napoleon particles move to the left.
Precisely. You need new, higher-level concepts. You need the concept of hunger, of monarchy, of freedom. These are real, powerful forces in the world. They move bodies, they change the map of continents, but they are invisible to the equations of physics.
It's like we have these different layers of reality. Physics is the concrete foundation in the basement, but we live up in the penthouse. And you can't describe the view from the penthouse just by analyzing the chemical composition of the concrete in the foundation.
That is a beautiful way to put it. Physics provides the foundation, but it doesn't explain the structure that's built on top of it. And this brings us to one last, more subtle limit, which is simply the fuzziness of the world, the problem of vagueness.
Vagueness. Physics hates vagueness. Physics wants 10 decimal points of precision.
Physics demands precision. Things are either P or not P. An electron has spin up or it has spin down. There's no in between. But just look at the macroscopic world we live in. When does a heap of sand stop being a heap if you take away the grains one by one?
Is it when there are 50 grains left? 49? There's no exact number. It's fuzzy.
When does a child become an adult? Is it the moment they turn 18? When does one species evolve into a new species? It's not a single generation. It's a long, slow gradient. Our world is filled with these borderline cases, and physics struggles with them because it assumes sharp boundaries that often just don't exist in the messy, emergent layers of reality.
So let's just take a quick stock here. We've covered the origin of the universe. Physics can't explain it. Consciousness, it can't find it. Free will, it can't prove it. Math, it can't explain why it works so well. Time, it can't explain the feeling of flow and meaning and morality. They seem to be totally invisible to the equations. It feels like we're painting a picture where physics is the canvas, but it's not the paint, and it's definitely not the artist.
I think that is exactly the right conclusion to draw. And this brings us, finally, to the ultimate limit, the final wall, the problem of the why questions.
We touched on this with the Big Bang, but this applies to everything in science, doesn't it? The chain of explanation has to stop somewhere.
It does. Science works by explaining X in terms of Y. Why does water boil? Well, it's because of increased molecular agitation. Why do molecules agitate more when heated? Because of the transfer of kinetic energy. Why does energy behave according to the laws of thermodynamics?
And you keep going down and down until eventually you hit the bottom.
You hit the bedrock. You arrive at the fundamental laws of nature. And then the child in us asks the final, impossible question, but why are the fundamental laws the way they are?
Why gravity? Why not something else? Why does the universe obey these specific rules and not some other set of rules?
And at that point, physics holds up its hands and says, I cannot answer that. Because in order to explain a law, you would need a deeper, more fundamental law. But if you found that deeper law, then the first law wasn't truly fundamental after all. And now you just have to explain the deeper law.
It's the child asking why, over and over until the parent finally just snaps and says, because I said so.
Exactly. Science must always, at some level, accept something as a given. It cannot be entirely self-explanatory. It cannot pull itself up by its own bootstraps. At the very heart of reality, there seems to be a mystery that science cannot penetrate, because science itself is built on top of that mystery.
So after all this, where does that leave us? We've spent this time meticulously walking along the edge of the map, pointing out all the blank spaces. Is this a depressing conclusion?
I don't think so at all. I think it leaves us in a place of profound intellectual humility, and that is a very healthy and very good place to be.
This isn't about bashing science. We started this whole conversation by celebrating it. We love science.
Absolutely not. It is the most powerful tool we have ever invented for understanding the physical world, bar none. But acknowledging its limits isn't a failure of science. It is a mature recognition of the complexity of reality.
It also seems to validate other ways of knowing, doesn't it?
It does, profoundly. If physics can't explain history or literature or ethics or consciousness, then that means those fields aren't just bad, fuzzy physics. They aren't just hobbies we do when the real work is done.
Necessary.
They are necessary. They are looking at the parts of the map that physics, by design, leaves blank. We need the philosopher, the historian, the artist, the theologian to help us understand the why and the ought and the meaning.
It's like we need a whole toolkit of different lenses. A microscope is a fantastic tool, but you can't use it to look at the stars. For that, you need a telescope. And you can't use either one of them to read a novel and understand the characters.
Or to understand a friend.
Right. If I want to understand you, I don't put you in a CT scanner. I talk to you.
Exactly. And I think there's one final thought that really captures this ultimate limit. It's a philosophical concept called the problem of particularity.
Ooh, I like the sound of that. What is it?
Well, physics is the science of universals. Its laws are universal. It says all electrons behave in this way. All masses attract each other according to this equation. It deals in generic rules that apply everywhere and everyone.
Right. An electron here in this studio is identical to an electron in the Andromeda galaxy. They're interchangeable cogs in the machine.
But for all its power with universals, physics cannot explain particularity. It cannot explain why this specific electron exists right here and right now. And, much more profoundly, it cannot explain why you are you.
What do you mean by that?
Why is your particular stream of consciousness attached to this particular body, living in this particular century in this particular place? Why aren't you someone else? Why aren't you living 1,000 years ago or 1,000 years from now? Physics explains the rules of the game. It explains how the biology works, how the atoms move, but has nothing to say about the specific allocation of the players to their pieces on the board.
That's actually haunting. It makes you realize that while we are completely a part of the physical system, there's something utterly unique and mysterious about our thisness, the specific moment, the specific person, that just slips right through the net of the equations.
It's a question for you, the listener, to ponder. If science maps the rules of the game, who or what set up the board? And are we just pieces being moved around by the laws of physics? Or are we somehow the players? Physics can tell us how the pieces move. It cannot tell us who the players are or why the game is being played in the first place.
And on that wonderfully dizzying note, we are going to leave you to stare at the ceiling and wonder about the game. This has been an incredible journey to the edge of the map.
It has. Thank you for walking to the precipice with me.
Thanks for listening, everyone, and keep asking why.
And don't be afraid if, sometimes, there isn't an answer.
We'll see you next time.